Now let's look at a formal definition for relative extrema and go back to example 1 and identify what we have officially. So to determine relative extrema, we have our same 2 steps as determining increasing and decreasing. Our first step is to find critical numbers of a function. That is found by setting f of x, or f prime of x rather, setting the derivative f prime of x equal to 0 and solving for x. Then our second step is going to be making that sign chart, looking to the left and to the right of our critical number. So we want to see what makes first a relative maxima. So let's draw ourselves a max next to this here. A relative maxima switches from rising to a 0 derivative to falling. Increasing to decreasing is what we're looking for. So we want a positive first derivative to start to a negative first derivative. We want to switch from a positive derivative to a negative derivative at our critical number c, and then we know we have a relative max. If instead we want to see what would make a relative min, we could draw another picture here. So a min would be decreasing to a 0 derivative to increasing. So we want to have a negative derivative to a positive derivative. Negative to 0 to positive would give us a relative minimum. And then we want to remember that if sign does not change, looking back at the previous page, if sign does not change, like here we went from decreasing to decreasing, that gave us no relative extrema. So if our sign does not change, we do not have a relative max or min at our critical number. So let's go back to example 1 and determine if there are any relative extrema. So flipping back a couple pages, we had this example here. We said we have our critical number at 5.5. We want to figure out, do we also have a relative max or min at that critical number? So we're looking at the sign change we have. So our sign change from our sign chart went from decreasing to 0 to increasing at our critical number. Just drawing that picture out. So does that look like a relative max, min, or neither? It would be a relative min to go from decreasing to increasing. It's going to be at our critical number 5.5. Relative extrema are only going to occur at critical numbers. And then we would need to plug in to find the y value of our point. So our original function is x squared, so we would do 5.5 squared minus 11 times 5.5. Just looking back at that original function is x squared minus 11x. So I'm plugging 5.5 into that, and the y value is negative 30.25. And that would be a point. So a point is the x. You plug in the x, that is your critical number, back into the original function. Remember, if you accidentally plug your x value of the critical number into the derivative, you're just going to get 0 out because it made the derivative 0. So be sure if you're looking for a y value, that's the only time you plug into the original function is for a y value, unlike use the derivative on a sign chart. So when you plug into the original function, your y value is negative 30.25. If you're just asked for a value, that means just the y value, so you'd only enter negative 30.25. The location means just the x value, so you just type in 5.5, that's the location of the min, but the full point is 5.5 comma negative 30.25.